All right, let's go ahead and get started. Welcome to the best presentation of FHIR DevDays, proclaimed by me. My name is Kevin Shekleton. Was anyone in here yesterday for the presentation? Okay, a few people. So for those of you who were, I apologize for the repeat of the introduction, but I'm a distinguished engineer at FHIR. I've been there for 15 years. I am responsible for several things, one of them being our newer interoperability solutions, like SMART on FHIR and implementation for CDS hooks. However, today in my presentation, I am not speaking with my FHIR hat on. So that FHIR hat just came off, and now I'm speaking just in terms of the CDS hooks project, where I'm the project lead on that. So today I want to talk about CDS hooks. But first, I want to talk about a problem with smart apps. So you all, I'm sure, are familiar with SMART on FHIR, the standard for interoperable healthcare applications. And one such smart app is the bilirubin chart app. But there's a problem with this app. You see, that app is only applicable if you're looking at a patient that is a newborn that's 120 hours in age or less. That newborn baby has bilirubin results that are either not documented, so you need to document them, or that the results are outside of the normal expected range. So if these conditions are met, you should run that smart app. However, how does the user know, how does the clinician know that that smart app is even available to them, that their hospital even has that? How do they know that all those conditions that I just listed out are met, so then they know to go run the app? And if they do know that the app is available, they know that the app is relevant to this clinical scenario, how do they know where to find that app in their workflow? Okay? So this problem right here is what was the initial use case for the CDS hooks project. Now, CDS hooks, after it was developed, it handles more than just this use case, but this is what drove us to initially create CDS hooks. So CDS hooks is a vendor-agnostic remote decision support specification. And it was created by the team that originally created SMART. It is open source under the Apache version 2 license. And it's an emerging standard with very, very widespread support from both EHR vendors as well as companies providing CDS services. And the slides, by the way, for anyone who's interested, I'll make them available, so you don't have to worry about trying to capture or write down any content here. So CDS hooks defines these things called a CDS service. CDS services are those remote decision support services that are invoked by the EHR, and it's hooked in via these things called hooks, which I'll talk a little bit about. When the EHR invokes the CDS service on these hooks, the CDS service then evaluates its rules and its own logic however it wants to, and then it returns decision support via this concept called cards that are displayed to the user. Now, when I say the CDS service gets to evaluate its own logic and write that however way it wants, I really mean that. So a CDS service could be written using just like procedural programming or like a flow chart. It could be based on a neural network. You could have a mechanical Turk, or it could even be completely random or a Ouija board. It doesn't matter. So the CDS service is in total control of how it implements its rules and logic, which means that the CDS service, or the company developing the CDS service, is not having to express that logic in some sort of grammar or conform to some sort of rule engine. It's like a black box to the EHR. Those hooks that I mentioned that are the points in time in which a CDS service is invoked right now are based upon user-initiated actions. So things like opening a patient's chart, or prescribing a medication, or viewing pending orders for signing. So these are the hooks that a CDS service can get connected into. Was there a question there?
Are there any hooks that are temporal, like every 5 minutes?
Not yet, but I'm going to get to that at the very end. So the hooks are largely dependent upon the capabilities of each EHR. So we expect that there will be some hooks that are certainly more prevalent or common, but the specification is not going to lay out, here are the standard set of hooks that everybody must implement, just because so much of the capabilities of the EHR are dependent upon what hooks that they ultimately are able to support. But certainly there are some hooks that we think will have very widespread support. Things like patient view, opening a patient's chart. That's something that we've seen every EHR that has implemented CDS hooks as a prototype is able to implement that particular hook. Medication prescribe is another very common one. So let's go through an example here. So imagine our clinician is prescribing the medication, so that's the medication prescribe hook. So at the point in time in which they select that medication to prescribe, the EHR will trigger a set of CDS services that are interested in that particular hook. So when they call the service, it passes context information to the service about, like, here's the patient in context, here's the clinician who's prescribing the medication, here's the actual medication that the clinician is trying to prescribe. The CDS service, again, evaluates logic using its own set of rules. It can leverage data from the EHR's FHIR server if it needs to, so it can reach back in to the EHR's FHIR server to get additional data that it may need. And then it returns its decision support, if it has any, in those things called CDS cards. And those cards get displayed to the user. So we might see a card that just has purely textual information. So here's a card that says, hey, the medication you're trying to prescribe costs $200 per month, and the patient pays $30. You might have a card that suggests to the user that they actually switch the medication that they're trying to prescribe in this case. So, hey, instead of prescribing medication X, why don't we suggest that you switch to medication Y? These suggestions are backed by FHIR resources. So the suggestions, which actually can be multiple, it doesn't have to be just a single action, it can be multiple actions, are all represented by FHIR resources. And then going back to our initial use case that prompted us to create CDS hooks is you can push a smart app to the user. So here's a card that says, hey, perhaps consider launching this smart application. So if we think about our bilirubin chart smart app, you can imagine a CDS service that on open patient chart evaluates to see is the patient within the age range that we care about, do they have the bilirubin results either not documented or outside the normal range, and if so, hey, why don't you use the bilirubin chart smart app, and that smart app can take the user to an experience that is much more feature rich and applicable to that particular context. So if we look at that same workflow, yes?
Go back for a second.
Sure.
Maybe two very quick questions. What kind of payload is sent in 1? And who decides the rendering in 3?
Excellent questions. And I just keep teeing me up for my next slides. So the first question was, what is that payload sent in step 1? And the payload comes through as just a JSON request. So it's a post request from the EHR to the CDS service. This is not the full request, but it's some of the more important fields here. So the particular hook that the CDS service is being invoked on, what's the FHIR server, a reference to the user, patient, encounter, and there's a few other additional fields here. The CDS service responds back if it has decision support with those cards, which really is just more JSON here. So it comes back with a responsive JSON, and the EHR is responsible for rendering the cards. By doing that, that allows the EHR to render that decision support in a close to as native way as possible. Native being the native existing decision support that the EHR already provides. So that the user ideally does not differentiate between this remote third-party decision support and the decision support that is native to the EHR or the healthcare organization. So those cards, the CDS service can return any number of cards, whether that be 0, 1, or many. Again, the EHR renders the cards however it sees fit. And the card only actually needs to have 3 bits of information that are required, but there's a bunch of other optional fields that you could return. The first is a concise summary of the decision support, which we've chosen arbitrarily 140 characters, though I guess we should raise that to 280. An indicator noting the importance of the card, which I'll talk a little bit about, and then the source of the decision support. So what is that source? So here is the minimal, this is a minimal representation of a card in JSON. So just those particular fields here, those 3 fields that I just went over. The indicator, we have 3 values: informational, warning, and hard stop. The only one to really note here is that hard stop is documented as that it should be something that is interruptive to the flow. But again, each EHR is rendering these cards, and they're also rendering how CDS hooks is incorporated into their workflow. So each EHR will implement this however they see fit within their system. Some common card examples here. So, and these example cards are not codified. So like this, when I say this is an informational only card, there's not a concept that is information only. It's just, I'm just saying this card, since it has textual information, we say it just as an information card. So here we've got our summary, which is that medication information. The details, which is an optional field, is further text around the decision support. And then our source here is from a company called RxCheck, and that's actually, if you notice, that's in blue there, which means that there's actually a hyperlink. So one of the optional attributes for source is you can have a link to the source as well. So a suggestion card is cards that have suggestions. Remember, the suggestions are backed by FHIR resources. And so here's a card that, again, has information, but then it's also got this suggestion to switch the order. In the JSON for the card, that is a suggestion field, and in this case, since it's switching the order, and if we imagine this is on the medication prescribe hook where the user is trying to already place an existing order, or new order rather, this would actually be 2 FHIR resources. The first would be to remove the order that the user is trying to place, and the second action would be to add this new order. And both of those 2 FHIR resources will be bundled together in a single suggestion. So that button really represents 2 things here: removing the order that the user is trying to prescribe and adding a new one. And then our Smart App link cards, here we have a card with a link to a Smart App. In this case, we're linking to a ASCVD risk calculator. Now, these 3 examples are not the only things that you can do with cards. You can actually mix and match all of this. So here is a card that incorporates everything that I just talked about. So that's textual information, a suggestion, and again, you can have multiple suggestions, and a link to a Smart App. You'll note here too that the text for the details of the card has a bit of markup here, and that's because we support GitHub flavored Markdown as the content type for that details field, which is how we've got a little bit of styling there. Yes?
For the links to other smart apps, are they deep links? Can you go to like a context in an application, or is it just opening the application?
Great question. So the question was, for Smart App links, does the link just take you to the launch URL of the Smart App, or are you able to deep link into the application? Right now, it's just to the launch URL. However, you are the 3rd use case, and I want to talk to you afterwards, because 2 other folks have asked for that same capability, and we have a GitHub issue for that. So that's something I expect us to address. But I'd like to capture your name and use case, because that'll help us to show support for that capability.
I mentioned, maybe my question is not relevant yet, but if there is, let's say, 100 services listening to the patient view hook, and you get 100 of these cards, or maybe 200 cards back, how would the EHR go about ranking these cards?
That's a great question. I'm going to save that for the end.
Okay.
And I'm going to skip over that content there, because in the interest of time, and like I said, the slides will be available, so there'll be more content than I'll be able to cover here today. So we've talked about CDS services and EHRs invoking them. Well, how does the CDS service know, or how does the EHR rather know how to invoke the CDS service? Like, where is it available? So a CDS service provider, so a company writing CDS services, needs to have a base URL. So in this case, it's example.com. And we have this endpoint that must live off of that base URL. It's called the discovery endpoint, and that has to be available at CDS-services. Okay? And then each CDS service, so imagine a company, Acme company, creates 3 CDS services. Each one of its CDS services would live off of, so base URL / CDS-services / and then an identifier for the service. So if you had 3 CDS services, that'd be 3 URLs, okay, or 3 routes here. Now our discovery endpoint, again, as I said, is available at /cds-services. This returns a JSON document that lists out all of the services that exist at that base URL. Okay? And the discovery endpoint just gives you some metadata about each one of the services that exist. So what hook the service is interested in being invoked in, the name of the service, that ID, and that ID there is how we know how to put that onto the URL there so the EHR knows how to call it. So what this means is that given just a base URL for a CDS service provider, the EHR can discover all of the CDS services that exist on there, and it knows how to call each one of them. Right? Now, let's talk a bit about security. So first, the EHR trusts the CDS services that it's invoking via the fact that the CDS service needs to be available at a TLS protected endpoint. So the EHR is in total control over what CDS services it calls. So it's not just blindly making calls to based upon user input or anything like that. It's something that's been configured in the EHR, probably based upon the organization's rules or some sort of business arrangement with the CDS service provider. But it trusts that it's calling services that it expects to via the fact that that CDS service provider is available at a TLS protected endpoint. Okay. Now, conversely, a CDS service trusts the EHR via a signed JSON web token or JOT that is provided to it on each call. All right. Because if you imagine, the EHR is the one initiating the calls to the CDS service, so it can just use TLS to ensure that I know that I'm calling the service I expect to call. But the CDS service is receiving calls from potentially multiple EHRs, all right? And so how does it know that the EHR calling it, or the organization calling it, is trusted to do so? Maybe it's a paid service, and so it only wants to accept calls from an EHR that has paid them. So every request comes with a signed JSON web token, and it can validate the signature and look to see, hey, is this from an organization that I've whitelisted and trusted? And so that's how the CDS service trusts the EHRs. And the FHIR server, so remember the CDS service, when it's executing, it's able to reach back into the EHR's FHIR server and get additional data about the patient. Well, the FHIR access token, so that's the OAuth2 access token that the CDS service would use to get data out of the FHIR server, is actually provided by the EHR in the request. The reason for this is that this is very unique, because if you think about it for smart apps actually, when they launch, they talk to the authorization server and request an access token and go through that whole kind of launch workflow. Well, with the CDS service, we did not want that kind of whole OAuth dance to occur every time the service was called, because the service is going to be called multiple times. On the open patient chart, that's just once when you open this chart. But imagine on the medication prescribed, or maybe a hook where you're viewing individual lab results, that's multiple calls to the CDS service. And so if the CDS service had to go through the whole OAuth2 dance, that would actually slow it down considerably. So, and in order to not have terrible performance, the CDS service would have to implement some sort of caching, which would get very complex for all the CDS services. Instead, since the EHR is able to trust the CDS service provider, we're saying it's responsible for obtaining the access token. It is much closer to the authorization server, and so it can work on an arrangement to cheaply generate access tokens that are very specific to the CDS service and are very short-lived to provide those to the CDS service. Now with that, yes, question?
Can the CDS service also retrieve data from other server, from third-party server?
Yeah, so the question was, can the CDS service retrieve other data outside of the EHR FHIR server? Absolutely. What we're seeing today is CDS services that retrieve data not only from FHIR, but also from their proprietary data. So maybe they've curated some data themselves, or maybe even public data that they reach out to. Yeah, you're not limited. That CDS service provider can do whatever it wants.
Is there any latency agreed or assumed?
No, but I'm going to cover that too at the very end. Yes?
You may have covered this and I missed it, but is there a way to to not notify the user? Like if you want to kick off an async process from one of these events without notifying the user, is that possible?
It is possible. So if you don't want to notify the user with anything, you just don't return any cards.
Okay.
So your service would still get invoked, but you'd return a response with an empty array of cards.
Got it. Okay.
Now, looking at that JSON web token, if you're not familiar with it, it's basically a JSON structure that is encoded and, in our case, signed. So the actual value sent to the CDS service is this big long string, but when you actually unpack this, you get back this JSON structure here, and quickly going through each of the fields. So there's just 5 fields, and the first is the issuer, so the ISS value, that's the URL that represents the issuer of the JSON web token. So this would be like some sort of URL that the EHR specifies that represents it. The audience parameter is the actual CDS service endpoint being called. So this allows the CDS service to know, one, with issuer, what EHR called it. With the audience parameter, it checks to see that the URL being called is the same URL that is accepting this JSON web token. That helps prevent against tokens from being sent to the wrong audience or the wrong CDS service provider. There's an expiry time for that token, so these tokens are time bound, so that you can't take a token that was created, say, a month ago and try to replay that to the same service. You know the time at which the token was issued, and then this last value is a nonce value to protect against replay attacks. So a CDS service provider that is well behaved would record the fact that it processed a token by this particular nonce value, and if it saw a token with that same value, it would say, oh, this is someone trying to do a replay attack. Yes.
Is there a way to pass the ID of the health worker who is accessing the EHR?
Yes, that comes, so the question was, is there a way to pass the ID of the clinician or healthcare provider who is going through and making this request? And yes, that actually comes through in the request to the CDS service. That's one of the values. And it's a link to the practitioner resource for the FHIR. Yes?
Probably a stupid question, but what would the benefits be if this compared to just using the transport layer implementation? No,
Great question. Yeah, there's no stupid question. So the question was, rather than using this, what about mutual TLS? And we actually have in our specification a note about mutual TLS that certainly can be leveraged. However, not all platforms support mutual TLS. So for instance, on mobile, there is not great support for mutual TLS on both Android and iOS. You can get it to work, but there's you have to jump through a lot of hoops. And also, if you are a browser-based application, so say you have an EHR that's a pure browser-based that in my computer I can use that. In order to get mutual TLS to work now, I need to install a certificate from that CDS service provider, assuming that the requests are coming from my browser. And so that's the challenge with mutual TLS.
it's a client server that
Yeah.
is
Okay. We have a fantastic resource with CDS hooks in our public sandbox. So that's at sandbox.cds-hooks.org. Our website is actually cds-hooks.org. The sandbox operates like a mock EHR. So when you launch this, and you can hit it from your phone, you basically will open up a patient's chart automatically, and it will call out to CDS services that we've got bundled in the sandbox here. And so on the left-hand side, you see all the cards that get returned back. We also have a mock medication prescribe workflow under the RX view there. You can switch patients. You can switch it to an arbitrary FHIR server, which is really cool. So the default FHIR server, has everything that you need to just kind of get started, but you can point it at your own FHIR server or a FHIR server from another vendor. On the right-hand side are all the requests and responses to the CDS services. So you can, if you know to use the network tab in like Chrome Developer Tools or Firefox Developer Tools and so forth, you can certainly look at the requests and responses that way. But here we've kind of got it face up there, so you can see everything. You can hook in your own CDS services into the sandbox, so you can do all of your testing here. And there's also a demo for those that aren't developers who have an idea for how they want their card to look. And you can actually just type in what you want the card to say, and it will spit out the JSON in real time for what your CDS service should return. Let's talk a little bit about separation of concerns as we wrap things up here. So for the workflow of how CDS hooks is incorporated and those hooks or the triggers, that's the responsibility of the EHR. So that's capabilities of the EHR. So what hooks are available in each vendor are going to depend upon the capabilities of their EHR. The CDS logic, again, comes from the CDS service provider, so it's a black box in terms of the EHR. That initial context data, like what's the user in context, what's the patient in context, what's the medication that you're prescribing, that all comes from the EHR and is given to the CDS service. Any additional data, the CDS service provider must obtain on its own, either via the FHIR server from the EHR or via other data sources that we talked about earlier. And the presentation of how those cards are rendered, how does it look to the user, that's all completely up to the EHR. Now, this is one of my favorite slides in the deck here. So here are 6 companies which have prototyped out CDS hooks in their EHRs at HL7 Connectathons over the past 2 years. And these are all of the CDS service provider or companies that have written CDS services at those same Connectathons. And this list just keeps getting bigger and bigger. We've got fantastic participation at our Connectathons, which is pretty cool. And it speaks a lot to the interest and the support in CDS hooks. Now, for those that are familiar with the Argonauts project, the Argonauts project is a consortium of EHR vendors and some healthcare organizations that all kicked in some money together originally to support FHIR and create the US core, or help fund the US core profiles. And basically, the vendors initially all said, hey, we're going to implement FHIR for the US market in this kind of same baseline way. Well, in 2017, the Argonaut project chose CDS hooks as a project that they wanted to focus on and invest in. And there was 2 things that we wanted to do with that. The first was to validate that our initial use case of pushing a smart app via CDS hooks was well supported, and we had really good implementer feedback on that. And so we ran through that earlier this year. The second thing was that security model that I talked about to implement that, which we did this past September at the San Diego Connectathon for the HL7 Connectathon. And we're actually right now going through a third-party security assessment, a threat assessment for our security model. And so Argonaut project is paying for that third-party auditor to come through and look at that. This is actually the same company that audited Smart on FHIR's security model a couple years ago when the Argonaut project was first created. So that same company is doing this again for CDS hooks. So what our immediate roadmap looks like is that we are working very hard on a release of a 1.0 specification. So we've not yet released the CDS hook specification. We were originally intending to do so by the end of the year, but our security assessment is scheduled to mid-January, and we're really then close to the January WGM with HL7 in New Orleans. And so we're just going to hold the release until the security assessment is done in mid-January, and we've got informal ballot feedback from the CDS working group and broader HL7 community at the end of January there. So we expect to release sometime shortly after there. There are production pilots that are in the works at various vendors, and those I expect to get publicity in 2018, which is pretty cool. And I know that there are some companies that privately have been doing things that based upon CDS hooks already in production, but I can't speak to those. But I'll let them speak to it whenever they want to. So 1.0, and this is going to get into some of your questions here. So after 1.0, what do we want to focus on? So first is performance. We don't say anything about that today. So if a CDS service takes 10 seconds to return, should the EHR wait for it? Is it allowed to just kill it after a certain amount of time? What should it do? How does it know if a CDS service is something that it can safely kill and it's not a big deal? Like the medication pricing CDS service example, where it said, here's the price of the medication. who cares if that never comes back, right? The clinician's not going to harm a patient. Well, financially they might, but you know, clinically they're not going to harm them most likely. But if it's an interaction checking service and it's, you know, the patient's allergic to the drug, like maybe this EHR should air out and tell the user, hey, I could not call the service and it was, you know, potentially crucial to your workflow. Trigger guards are a concept of, we can think about it in terms of that bilirubin chart smart app and the bilirubin CDS service. So it's only applicable for patients, for newborns that are 120 hours in age or less. Well, if that bilirubin CDS service was hooked into every time a patient's chart is open, that's being called a lot of times. And if the EHR could just put in like a trigger guard or a hook guard, whatever you want to call it, that basically says, well, I'm just going to look at the patient's age, which is a pretty simple check. And if you tell me that the patient, that you need the patient to be, you know, 120 hours of age or less, I'll only call you in that scenario. So it prevents the EHR from making a bunch of unnecessary calls. To your question earlier, event and time-based hooks. This is something that has come up quite a bit, and we know we want to support. So, you know, a CDS service being invoked for an event, not a user-driven action, but like event like a patient is registered in the system or a patient's transferred. So maybe it's not a user is actually doing something, it's some sort of event-based action, or a time-based hook. So every day the CDS service gets invoked. The big question for both of these things is where does the decision support go to? Because there's not a user at the keyboard at that point in time. And so where do you send that? You know, does it go to the care team? Does it go to some queue? That's something that that is really the only thing blocking that. And then finally, very specific clinical use cases, many of them driven around either regulation or government factors. So things like, these are US examples, but radiology orders have to go through decision support. That's the ACR ordering guidelines. The CDC in the US has issued opioid guidelines for prescribing those type of medications. And so we want to have most likely implementation guides that specify for these particular use cases, here's how you can satisfy those with CDS hooks. Now, let me hold the questions here because I've got just a few minutes left. You might be thinking, for those who are familiar with FHIR, wait, doesn't FHIR already define approach to CDS? And in fact, it does. If you look at the FHIR homepage, there's like all these levels, and the most top level, and it's super smart because it's got a brain there. There's a thing called clinical reasoning. And actually, there's a presentation later today, and Bryn Rhodes is going to give a presentation on clinical reasoning, so I'd encourage you guys to attend that. It's in this room later today to hear more specifically about clinical reasoning. And there's some differences about between clinical reasoning and CDS hooks. So first, clinical reasoning comes from HL7. CDS hooks right now is an open source project that is moving into HL7. So that's one difference. Clinical reasoning defines how you would define rules, so it defines this language called CQL that lets you express rules in a particular grammar. CDS hooks doesn't do any of that. Clinical reasoning supports local execution of those rules, so it doesn't have to be a remote service, it can be locally within the organization. It defines how you execute those rules. And then remote execution, actually both standards originally defined, or clinical reasoning originally defined a way to do remote execution, and obviously that's what CDS hooks is all about. Wait a minute. Doesn't more check marks? It's 3 check marks to 1, so clinical reasoning should win, right? Well, it's really different in the scope and the focuses of the two projects. So with clinical reasoning, it does a very great job at the rule definition or the knowledge artifact definition and that local execution. There's certain environments in which you need everything to occur within the context of the EHR and not cross those bounds. CDS hooks very good at remote decision support, and so there's a bit of overlap there. And so what we've been working on this actually since January, Bryn, myself, and another colleague, Isaac Vetter from Epic, we've been working on kind of harmonizing the two projects, and the remote pieces of clinical reasoning have been removed in favor of CDS hooks, and we're making these projects align, so they're not directly kind of butting heads or competing with each other. So they work nicely together. So it's not that CDS hooks replaces clinical reasoning. It's not clinical reasoning replaces CDS hooks. It really depends upon your use case, and if you want to express your logic and decision support in a standard knowledge artifact, then that'd be a case where you use clinical reasoning. If you're wanting to develop a black box CDS service that gets invoked, and you implement that however you want, then you use CDS hooks. So I'm going to jump ahead here. Let's get these questions. Okay, I've got some references here which you can see later, and I have a exercise here for everyone. So, and this handout just has this URL up here, so if you want one, please grab one here at the end. But basically, this will walk you through creating your very first CDS service and incorporating it into the CDS hooks sandbox. It's pretty easy and quick to go through, and I'd love to see a bunch of you folks go through this. I will be at the CDS table, and I'll keep one of these at the, well, I don't need one at the table, but I'll be at the table if anyone has any questions today or wants to go through it. And thank you all for your time, and I'll be happy to take any questions in the remaining probably minute that I have. Yes?
Yeah, there was a project OpenCDS, which was HL7 VMware based, right? So that was also black box, right?
So
yeah, this is also black box. Like what I'm seeing, this is just different architectural differences that we have. So what is the planning for that project that they have already established VMware standards and many interfaces? So is there any planning for CDS hook to align with that already available?
yeah, so the question was around OpenCDS and what's our plan to align with that. I'm not super familiar with OpenCDS, but I know Ken Kawamoto from University of Utah is kind of the lead over OpenCDS, and I've talked to him a few months ago about that. He said that they're updating OpenCDS to use CDS hooks, but I don't have specifics on the details around that other than that. So they shouldn't be conflicting.
Yeah, because if this is moved towards HL7, so there will be two standards which is working on the same area. So whichever to pick, then people will have to decide that this is like something from external perspective.
So I can if I can speak a little to that. So the standard that OpenCDS is based on is Decision Support Service from HL7. We a couple years back tried to restify it, but it didn't get a lot of adoption. And so what is great about CDS hooks is that it's got this groundswell and this adoption, and so there's no plan to try to keep that DSS alive if no one's using it. If people are using it, then HL7 would support that usage. But the plan, especially from an OpenCDS perspective, is to use CDS hooks as the RESTful version of that DSS specification.
One more question. Time for one more. All right. Oh, Lloyd.
FHIR versions.
FHIR versions. Great question. So we've purposefully kept CDS hooks separate from FHIR so that we can actually support multiple versions. The one interesting bit that we have is, and this is something that we have a GitHub issue for that we need to address, is how does the CDS service advertise what FHIR version it wants or can handle? Because some FHIR data comes through the context, like when medication prescribed, the medication that the user is prescribing it's a FHIR resource. So how does the HR know what version of the FHIR resource to send the CDS service? And how does the CDS service, when it returns the cards and suggestions, know what version of FHIR the HR is capable of handling?
Can you even go further than what version, but talk about what profile the data has to meet for it to be useful to you?
That is certainly something that, that seems to make sense. But like I said, we haven't worked through this. We have a GitHub issue for it, though. We have GitHub issues for a lot. So anyway, if anyone's interested, I've got the handouts here for the tutorial. I'd love to see you guys create your own CDS service today. Thank you.